All right, folks, let's do number one. A motorcycle drives south at 20 meters per second for 3 minutes, then turns west and travels 25 meters per second for 2 minutes, and finally travels northwest at 30 meters for 1 minute. For this 6-minute trip, find the total vector displacement, the average speed, and the average velocity. Let the position, all right, be x, point towards the v. So I encourage you to pause this video and to give this problem a shot. Let's get started. So let's mark the origin here. So here you have a motorcycle, and she drives 20 meters per second down south. So if you were to do the math, 20 meters times 3 minutes, so I'm going to write this down. So 20 meters per second times 3 minutes. And then turns west and travels 25 meters for 2 minutes. So she travels west and travels at the distance of 25 meters per second in the course of 2 minutes. And then finally travels northwest at 30 meters for 1 minute. So after 5 minutes, she travels 30 meters per second northwest, so that's implying 45 degrees, 30 meters per minute times 1 minute. So I don't know exactly what this vector displacement is going to look like, but this is the general picture. If this is the origin, we'll see where this point lies. But the overall displacement is L, or R. I'm going to call it R. And R is going to be the position. In fact, let me calculate these values, folks, and I'm going to presume you know how to convert from minutes to 60 seconds. So put that all in there, calculate this. All right, folks. So I'm going to redefine the vector r, and this is the coordinate, as the position here, where it goes from the x and to the y. So I'm going to write it in my own notation. So this is going to be x, y. X is going to be the value of negative 3,000 meters. That's this component added to this extra piece of component, which is going to be minus 1800 meters divided by root 2, because that's 45 degrees, and that's it. So y is going to be 3,000 meters. Oh, my bad. 3,600 meters plus 1,800 meters over root 2. So once you get your vector, that's the answer to part A. Part A is going to be the values of, so once you get your values, your x will be negative 47. All right, let me try again. Negative 4272.80 meters. I like to round it to decimal places, but you don't really have to round it that far, to be honest. Minus 2327.21 meters. So I'm going to convert this to kilometers. So I'm going to write my final result as the vector A being negative 4.27 and negative 2.33 meters, or kilometers. And there we go. So there we go, folks. This is going to be the vector. What I'm going to do is I'm going to find the magnitude and the direction. I'm going to define the angle as to all the way from the starting from the east axis. So the magnitude here is 4.86 kilometers. However you guys want to round this, it doesn't really matter. And the direction is, I'm going to take the tan inverse of y divided by x, and that's going to be the angle. That's going to be this angle that we're going to add to 180 degrees to get the correct angle. So this theta is going to be 208.5 6 degrees. Beautiful. We're done. So that was part A. Now let's answer part B. The average velocity. No, the average speed. All right, so this one is a little interesting. This is going to be the average speed over the whole course of 6 minutes. So since we're talking about speed, we're not talking about the actual direction. And when they're asking for average speed, folks, that's just another way of saying add them up. Because if you went to a city, you turned 20 minutes, 20 miles in this direction, and then you went 20 miles east and 20 miles north, or whatever the heck, you traveled a total distance of 60 miles. The same thing with speed, folks. We're just going to add them up. So we're going to take 20 meters per second plus 25 plus 30. 20 meters per second plus 25 meters per second plus 30 meters per second, and we're going to add this into minutes. So the whole total is 3 minutes, 5 minutes, 6 minutes. So it's 6 minutes, but I'm going to convert that to 60 seconds to convert this. So this is going to be the average speeds. I'll call it S or something. I don't really care. So the speed of this, the average speed of this motorcycle, motorist, is going to be so I got the value of 0.208. However, I'm going to keep the minutes, so I'm going to read this as the average speed being 12.5 meters per second per the course of a minute. Or maybe it's just that. Okay. I'm a little confused right now. Oh my god, I can't believe I'm confused. The average speed, it does say average. Let me see what the answer in the back says. I'm just a little curious. All right, folks, that was not successful, but that's all right. I don't memorize anything, but yeah. So the average speed is actually the total distance it traveled. Okay, so we're going to be adding 3600 plus 3000 plus 1080. That's what it was. Oh my god. Oh, yeah. This is embarrassing. That's all right. And I'm recording a video for you guys that are wanting to learn. I don't know. So this is the total distance traveled or the course of 6 minutes, which is going to be, so I'm going to put that. So I'm going to put 3600 plus 3000 plus 800, which actually makes more sense. I just, yeah, perfect. Okay, so this actually makes sense. Okay, so the average speed is going to be, I don't know if I edit that part of the video out. I deleted a bunch of stuff. It's 23.33 meters per second. All right, part C. But I will try to answer these correctly, so I will memorize these definitions and everything. I mean, you have to. So let the average velocity, let the position, okay. The average velocity. All right, now we're going to talk about the average velocity. The average velocity, I am pretty sure it's going to be this magnitude divided by 6 minutes. So I'm going to take the magnitude of this, which I have this stored in my calculator. 4.86 kilometers, or another way of saying 4.272.52 meters to be exact, divided by the course of 3600 seconds. So that's going to, is that the answer? Let me double check this. I don't know what I put. 660. Yeah, that should be the answer. Unless I'm thinking this wrong. What the fuck? Oh my god, I did the Pythagorean theorem wrong. Oh my god. Oh my god. Forgive me, folks. I am such an idiot. 4865.4 0.45 meters. There you go. Okay, so you take that divided by 360.00. And actually that's got to be fixed too, because it's just 360 seconds. There we go. So that's the average velocity. So the average velocity, I don't know how to notate this, to be honest. It's going to be 13.52 meters per second. And we're going to take the angle. Well, the angle is going to be, I took the whole Pythagorean theorem, so I'm going to take in the direction of that. So I'm going to put 208.6 degrees as my answer. All right, folks, we are done.